15th April, 1986. American pilot Brian Schul is racing through the stratosphere at an altitude of 25 kilometers over the territory of Libya, where the bombing of Tripoli has just ceased. His aircraft is a Black Arrow more than 30 meters long, flying at a speed 3 times the speed of sound. At such an altitude, the sky overhead is almost black, and the horizon curves in an arc, as if looking at the Earth from space. Not a single fighter in the world is capable of climbing here. Not a single missile in the more than 20 years of this aircraft's existence has managed to reach it. But suddenly, the instrument panel is flooded with red light as a warning. Libyan anti-aircraft systems of Soviet manufacture have somehow locked onto the target. Missiles are already heading up. The pilot has one single option: give full throttle and try to escape from what is impossible to escape. Will he succeed? And what kind of machine is it that can even afford to compete with an anti-aircraft missile in speed? To understand this, one needs to rewind time 26 years when it all began. May 1st, 1960, over the territory of the Soviet Union, an event occurred that overturned all American reconnaissance aviation. The high-altitude spy plane U-2, piloted by Francis Gary Powers, entered Soviet airspace at an altitude of more than 20,000 meters, being absolutely confident in its own invulnerability. For several years, such flights took place with impunity because not a single anti-aircraft complex and not a single interceptor could simply reach this altitude. But Soviet engineers were not sitting idle. And on that day, a new anti-aircraft missile of the S-75 complex reached Powers' aircraft, damaging it so much that the machine began to fall from a height of 21 kilometers. The pilot managed to eject and survived, but was immediately captured on the ground. Washington tried to get out of it by stating that it was just a meteorological aircraft that accidentally strayed from its course. However, the Soviet Union organized a public press conference at which it demonstrated the wreckage of the machine, the spy equipment, and the living pilot himself. The diplomatic scandal turned out to be deafening. The planned summit between Khrushchev and Eisenhower was disrupted. Relations between the two superpowers escalated to the limit. But for the American military, the most terrifying thing was not even the diplomatic humiliation, but the simple realization. If the Russians shot down one such aircraft, they would shoot down the next. The era of the U-2 as an invulnerable scout ended in an instant. The answer to this crisis was to be given by a man named Clarence Johnson, a legendary aircraft designer and head of a secret division of the Lockheed Company known as Skunk Works. It was Johnson who created that very U-2. And even before the incident with Powers, he perfectly understood that sooner or later, Soviet air defense systems would grow to the flight altitude of his creation. Therefore, long before the catastrophe over the Urals, he was already working on the concept of a fundamentally new aircraft that would fly so high and so fast that no existing or even prospective air defense system could reach it, and its reflection on radar screens would be so tiny that operators would take it for interference or a bird. After the incident with Powers, pressure from Washington became unbearable. The CIA and the Pentagon demanded a solution immediately, and Johnson promised the impossible: to create an aircraft capable of flying at an altitude of more than 24 kilometers, at a speed of over 3 speeds of sound, and to do it in 20 months. Any other aircraft designer on the planet would have called such a time frame madness, but Johnson was used to doing the impossible. The project received the designation A-12 and the highest secrecy classification. Work was in full swing at a closed facility in Burbank, surrounded by fences higher than at most nuclear facilities, and tests were planned at a top-secret base in the middle of the Nevada desert known as Groom Lake. Much later, the whole world would know this place by another name: Area 51. Johnson's team faced tasks that no one in the history of aviation had solved before them. When flying at a speed 3 times the speed of sound, the leading edges of the aircraft heat up to 550 degrees Celsius. Aluminum, from which all aircraft of that time were built, loses strength and deforms at such a temperature. The only suitable material turned out to be titanium, light, strong, and heat-resistant, but incredibly temperamental in processing. Ordinary steel tools, upon contact with titanium, caused cracks in the workpieces, and engineers had to develop a special tool from scratch, also from titanium. Up to 80% of the supplied metal was rejected due to the smallest impurities. Every day brought a new problem that seemed unsolvable, but Johnson's team solved them one after another, literally inventing technologies on the go. And exactly on the promised date, in April 1962, the first prototype was ready. Ahead of it lay the sky. When the A-12 prototype was rolled out of the hangar in Burbank, it amazed even those who built it. Aviation had known nothing like it yet. Instead of the usual rounded shapes, a predatory swept wing machine with flat fuselage sides and sharp ribs stretching from the nose to the wing root stood before the engineers. These ribs, which received the name Chinese, became a real engineering breakthrough because they simultaneously solved three tasks at once. They created air vortices improving stability at enormous speeds, gave additional lift, and scattered signals from enemy radars away from the source. The vertical stabilizers were tilted inward, and serrated sections covered with a special radio-absorbing material were located all over the body. In fact, Johnson's team created the world's first aircraft with elements of stealth technology long before the word stealth itself came into use. April 30, 1962, test pilot Louis Schalk took the prototype into the air from a secret runway in the middle of the Nevada desert. The aircraft did not yet carry its famous black paint. It shone with natural titanium silver under the scorching sun. The first flight was cautious. The landing gear was not retracted. The speed did not exceed 550 kilometers per hour, and the altitude was 10,000 meters. Schalk spent 35 minutes in the air, checking the basic behavior of the machine, the design of which had no analogs in world aviation. Everything went according to plan, and the test program began to rapidly gain momentum. With each subsequent flight, the pilots raised the bar higher and higher. July 20, 1963, the A-12 for the first time steadily exceeded 3 speeds of sound at an altitude of 24,000 meters, breaking records literally during every flight. Radar signature measurements confirmed a fantastic result. The reflected signal turned out to be 90% weaker than that of a conventional aircraft of similar dimensions. For enemy radars, this 30-meter machine looked no larger than a sparrow. But along with records came problems that no one wrote about in aerodynamics textbooks. At a speed of Mach 3, the usual landmarks for navigation completely lost meaning. Highways, rivers, cities, all of this merged into an indistinguishable spot under a wing flying almost 1.5 kilometers in 1 second. Pilots quickly realized that the only thing the eye could catch at such a speed was mountain ranges, coastlines, and large bodies of water. A separate puzzle was represented by the fuel system. Ordinary aviation kerosene on board this aircraft would have exploded from just the heating of the skin, so a special fuel was developed for the A-12, which received the index JP7. The ignition temperature of this liquid was so high that technicians at the base amused themselves by throwing lit cigarettes directly into the container with fuel. The flames simply went out, as if in water. But this wonderful safety turned into a very serious engineering problem. If the fuel is practically impossible to ignite, how to start the engines? The solution was found in chemistry. Triethylborane was used for ignition, a substance so active that it spontaneously ignites upon the slightest contact with air. Each of the 2 engines carried a supply of triethylborane for exactly 16 starts, and during every startup or afterburner activation, a characteristic green flash burst out of the nozzles, which pilots learned to perceive as a good sign. It meant everything was working normally. The Pratt and Whitney J58 engines themselves were no less revolutionary. During takeoff and acceleration, they worked as ordinary turbojets, but as speed was gained, they smoothly transitioned to the ramjet mode characteristic of cruise missiles. Each produced a thrust of more than 11 tons on afterburner, accelerating the aircraft to 3,400 kilometers per hour. To control the monstrous flow of air rushing into the air intakes at triple the speed of sound, engineers created a system of moving cones and bypass doors that automatically adjusted to the current flight speed. Another legendary feature of this machine: it leaked while standing on the ground. The skin panels were specifically made with gaps because when heated during supersonic flight, the titanium expanded, and only then did the joints close tightly. At the parking lot, however, JP-7 fuel seeped through the cracks, forming puddles under the fuselage. Technicians got used to this sight, although it invariably led newcomers to horror. After the completion of the test program, the A-12 moved from the category of experimental machines to the category of combat scouts. In 1965, when the Vietnam War was gaining momentum, the CIA began transferring aircraft to the Kadena Air Base on the Japanese island of Okinawa. The operation received the code name Black Shield. The machines made sorties over North Vietnam and North Korea, obtaining reconnaissance data that satellites of that time could not give. The flights took place in absolute secrecy, and the pilots were civilian CIA employees working under unofficial cover. In case of capture, they were not protected by any military conventions, and they knew this perfectly well every time they climbed into the stratosphere over enemy territory. While the CIA was flying over Asia on its A-12s, the American Air Force was preparing its own version of this machine. The Air Force ordered their version from Lockheed back in December 1962, and the requirements for it differed significantly from the CIA original. The military needed not a single seat scout for short dashes, but a full-fledged two-seat machine for long, multi-hour missions. The aircraft turned out to be longer and heavier than its predecessor, primarily due to an increased fuel supply and a second cockpit located directly behind the pilots. In this rear cockpit sat a reconnaissance systems operator who was responsible for navigation and managing all onboard spy equipment during the flight. While the A-12 had mainly a powerful camera, the new machine carried a whole arsenal of reconnaissance means: electronic intelligence equipment, a side-looking radar capable of seeing through clouds, and several different photo systems simultaneously. The fuselage received redesigned contours, and the engine nacelles were re-engineered anew. By 1964, when the Cold War had heated to the limit, big politics intervened in the fate of the secret aircraft. It was an election year, and the Republican presidential candidate Barry Goldwater fiercely criticized the current administration of Lyndon Johnson for an alleged lag behind the Soviet Union in the development of new weapons. Johnson decided to respond to this criticism in the most spectacular way. He publicly revealed the existence of an entirely secret program, telling the whole world about a new reconnaissance aircraft. During his speech, the president called the machine RS-71. However, the Air Force Command, led by General Curtis LeMay, insisted on the designation SR, which stood for Strategic Reconnaissance. As a result, the military designation SR-71 stuck to the aircraft, although the president himself pronounced the original version in his speech. In the same year, the machine received its legendary black paint. The decision was not aesthetic, but purely engineering. Black paint on a ferrite basis best absorbs and simultaneously radiates heat, helping to more evenly distribute the monstrous heat over the entire surface of the airframe during supersonic flight, and at the same time further reduced the radar visibility of the aircraft. It was thanks to this ominous black appearance that the aircraft received the name that traveled around the whole world: Blackbird. December 22, 1964, test pilot Bob Gilliland, for the first time, took the SR-71 into the air from the factory airfield in Palmdale, California. A little more than a year later, in January 1966, the first machines entered service with the Strategic Reconnaissance Wing at an air base in California. Unlike its predecessor, which flew without markings with civilian pilots on board, the SR-71 carried full military Air Force designations, and its crews were career officers carrying Geneva Convention YD cards in case they were shot down over foreign territory. March 21, 1968, Majors Jerome O'Malley and Edward Payne performed the first combat mission of the SR-71 from Kadena Base on Okinawa, collecting reconnaissance data over North Vietnam. Local personnel on Okinawa nicknamed the ominous black machine Habu after a venomous pit viper inhabiting the islands. The nickname stuck and became the second unofficial name of the Blackbird among everyone who worked with it. Flying at an altitude of more than 25 kilometers, the SR-71 could survey a territory with an area of 260,000 square kilometers in 1 hour. The aircraft's cameras could distinguish objects 15 centimeters in size from working altitude, and the onboard side-looking radar pierced through any cloud cover, tracking the movement of equipment on the ground. But all this equipment would have been useless if the crew did not return alive. A flight on the Blackbird had nothing in common with ordinary aviation. Before each mission, the pilot and operator underwent a medical examination, after which they received a special meal of steak and eggs, a high-protein diet with a minimum of residue, designed for long hours in a cramped cockpit without the possibility of using a normal toilet. Then the crew donned pressure suits, almost identical to the spacesuits of the Gemini program astronauts. Without these suits, a flight at working altitude would mean instant death. At 25 kilometers, the pressure is so low that blood boils in the veins without forced pressurization. And if the pilot had to eject at a speed of Mach 3, the friction against the incoming air would instantly heat his body to 230 degrees. Those who were lucky enough to fly on this machine described sensations accessible to no one else on the planet, except for a handful of astronauts. Air Force Colonel Jim Watkins recalled that at an altitude of 26 kilometers at a speed of Mach 3, he experienced something close to a religious experience, and that even years later he gets goosebumps from these memories. Pilots looked up and saw an almost black sky, and below, the world rushed by at a speed of 15 kilometers per second. At the same time, the temperature of the outer glass of the cockpit reached 315 degrees, and the inner surface warmed up to 120. The crews quickly came up with a practical use for this. Colonel Rich Graham told how he pressed a tube with onboard rations to the red-hot glass for 1.5 minutes on each side, turning the windshield into an improvised oven, because warm food at such an altitude went down much better than cold food. Over the years of service, the standard tactic of Blackbird crews upon detecting the launch of anti-aircraft missiles was disarmingly simple. Just give it gas and fly away. No anti-missile maneuvers, no traps or diplomatic tricks, only pure speed. And this tactic worked flawlessly. Throughout the history of operation, more than 4,000 anti-aircraft missiles of various types were fired at the SR-71, and not one of them reached the target. Not a single hit over decades of flights over the most hostile territories of the planet. The few machines that were lost during the program, and there were 12 of them, perished exclusively due to mechanical failures, not from enemy fire. One of the most significant missions of the Blackbird was reconnaissance during the Arab-Israeli War of 1973, known as the Yom Kippur War. When the hostilities reached a critical point, President Nixon personally demanded reliable reconnaissance data on the real position of troops on the front line. Both sides of the conflict claimed they had withdrawn their forces from the front, as required by the terms of the ceasefire. But Washington did not believe them. The Blackbird crew received the task of making a dash from the east coast of the United States across the Atlantic to the Middle East and back, covering thousands of kilometers at supersonic speed. The photographs the crew brought back irrefutably proved that both the Arab and Israeli sides were lying about the location of their troops. Nixon called both governments and stated that he had photographic evidence of their deception, demanding that they immediately withdraw their forces to where they were obliged to be. This reconnaissance mission of a single aircraft actually helped stop the war. In peacetime, the Blackbird set records, each of which seemed like fantasy. September 1, 1974, Major James Sullivan and operator Noel Wyford flew from New York to London in 1 hour, 54 minutes, and 56 seconds, maintaining an average speed of about Mach 2.72. This is taking into account slowing down for aerial refueling. For comparison, the supersonic Concorde covered the same route in almost 3 hours, and a conventional airliner spent more than 6. July 28, 1976, the Blackbird set 2 world records at once, which have not been broken to this day. Captain Robert Helt and operator Major Larry Elliott took the machine to an absolute record altitude of steady horizontal flight of 25,929 meters or 85,069 feet. On the same day, another crew, Captain Eldon Jorce and Major George Morgan, accelerated the SR-71 to an absolute speed record, 3,529 kilometers per hour, which corresponds to approximately 3.32 Mach. Half a century has passed, and not a single manned aircraft in the world has managed to surpass these figures. During patrol flights over northern Europe, Blackbird crews sometimes, with exceptional visibility, noticed Soviet interceptors far below, unsuccessfully trying to catch up with the black machine in the stratosphere. Even the MiG-25 Foxbat, the fastest fighter in the Soviet arsenal, capable of accelerating to 3,000 kilometers per hour, could not approach the Blackbird, which every time pulled away at a speed inaccessible to any other flying craft with a person on board. But June 29, 1987, an incident occurred that showed that the Blackbird was not immortal after all. During a standard mission code named Baltic Express, laid along a narrow corridor of international airspace between Sweden and the Soviet bloc countries, an engine explosion occurred on board one of the SR-71s at an altitude of about 20,000 meters. The crippled machine lost control and intruded into Swedish airspace while the pilots desperately fought for control. The Swedes scrambled unarmed Viggen fighters into the air, which assessed the situation and took the damaged Blackbird under escort, leading it toward Danish airspace. What remained classified for more than 30 years was that simultaneously with this, the Soviets scrambled several MiG-25s with orders to destroy the helpless scout. National Security Agency data, declassified much later, showed that one of the MiGs managed to lock onto the Blackbird with a missile. But the presence of Swedish fighters near the damaged machine probably deterred the Soviet pilots from launching. In 2018, 4 Swedish pilots who participated in that escort received medals from the United States Air Force, 3 decades after the events about which they had remained silent all that time. Now it is time to return to that very episode with which our story began. April 15th, 1986. Libya. Several hours earlier, American aviation had struck Tripoli in response to Libya's support for international terrorism. Major Brian Schul and his reconnaissance systems operator, Walter Watson, received the task of passing over the strike zone and recording the results of the bombings. Their SR-71 entered Libyan airspace at standard altitude and speed. But a series of course corrections for precise aiming of the cameras at the desired objects forced the crew to temporarily reduce speed. This brief slowdown turned out to be enough for outdated Libyan anti-aircraft batteries of Soviet manufacture to manage to lock onto the target. The instrument panel flashed with warnings of radar lock from several directions at once. Anti-aircraft missiles were already heading up, gaining altitude with every second. Schul did not waste time thinking and pushed the throttle levers forward to the limit beyond normal operational restrictions. The Blackbird responded instantly, pressing the crew into their seats with the acceleration load. The aircraft accelerated so rapidly that the speed indicator needle went past the last mark on the scale, graduated to 3.5 Mach. Schul later recalled that the machine was flying faster than any of them had ever seen, and that they at that moment simply did not know their exact speed, because the instruments were not designed for such numbers. The missiles gaining altitude behind them began to fall behind, and then were left far behind the tail, unable to keep up with the black machine, which once again surpassed its own official characteristics. Schul and Watson returned to base with a full set of reconnaissance photos, proving in the most graphic way why throughout history not a single Blackbird was lost to enemy fire. No, как это ни парадоксально, the invincible machine was ultimately brought down not by an enemy, but by the budget. By the end of the 80s, the cost of one flight hour of the SR-71 was from $85,000 to $200,000. Each aircraft could fly on average only once a week due to the colossal volume of technical maintenance. The machines often returned with torn-out rivets, peeled-off panels, or damaged air intakes, and sometimes repairs dragged on for an entire month. The special JP-7 fuel required its own dedicated KC-135Q tankers for aerial refueling. Critics argued that satellite reconnaissance had made the Blackbird unnecessary, although supporters of the program rightly countered. Satellites fly in predictable orbits, and the enemy knows in advance when to hide equipment, and the SR-71 could appear suddenly and deliver photos in a matter of hours, not days. Nevertheless, in 1989, for political and financial reasons, the Air Force decided to decommission the entire fleet of Blackbirds. Но прежде чем черная птица ушла на покой, she was given a farewell worthy of a legend. March 6, 1990, Lieutenant Colonels Ed Yielding and Joseph Vida took the SR-71 into the sky for the last flight in Air Force history from Los Angeles to Washington, where the machine was awaited by the National Air and Space Museum at the Smithsonian Institution. What happened next became the final triumph of the Blackbird. The distance between the two coasts of America was covered by the aircraft in 67 minutes and 54 seconds at an average speed of more than 3,400 kilometers per hour. During this flight, the crew set 4 new speed records at once on various segments of the route, including a flight from St. Louis to Cincinnati in 8 minutes 32 seconds. According to aviation publications, on one of the segments, the machine accelerated to 3,600 kilometers per hour, which corresponds to almost 3 Mach. 2 days after this flight, Senator John Glenn, the first American to make an orbital flight around the Earth, spoke before the Senate, calling the decommissioning of the SR-71 a gross error that puts the country at a disadvantage in case of a future crisis. His words proved prophetic. Just a few months later, during Operation Desert Storm, General Norman Schwarzkopf requested Blackbird reconnaissance, which no longer existed. In 1994, Congress allocated $100 million to return 3 machines to service, and from 1995 to 1998, they again performed combat missions until final decommissioning put an end to it. But even then, 2 machines continued to fly under the auspices of NASA as research platforms. October 9, 1999, at an air show at Edwards Base, a NASA crew consisting of Roger Smith and Robert Meyer took the Blackbird into the sky for the very last time, accelerating the machine to 3.21 Mach at an altitude of more than 24 kilometers. After this, the aircraft returned and passed over the spectators 3 times at low altitude. People on the ground cried, watching as the black silhouette dashed over the airfield. They understood that they were seeing the end of an era that would never be repeated.